Now that we've had a chance to work with our sine and cosine graphs, let's look at tangent and cotangent. I'm using my unit circle definitions, whereas tangent of theta is equal to y over x. And so looking at our unit circle off to the left, here at 0, 2 pi, negative 2 pi, 4 pi, and so on, our x and y values are 1 and 0. That means that any even multiple of pi, such as 2 pi, 4 pi, negative 2 pi, negative 4 pi, negative 18 pi, our value for tangent is going to be 0 over 1, which would be 0. So we can mark those on our graph, and we know that we're going to be 0 at negative 2 pi, at positive 2 pi, at 0 pi. These are points where our tangent is going to be 0. But if we look at the pi, our odd pi's, pi, 3 pi, 7 pi, negative 3 pi, at these points we also have 0. It's 0 over negative 1, which is still 0. So at every multiple of pi, whether it be odd or even, tangent is going to be 0. And I'm going to write this y equals tangent x. I know that we're saying up here tangent theta equals y over x, but now we're looking at tangent as a function in its own, and we're graphing it with x being our angle and y being our tangent of that angle. So I know that gets a little confusing. Just try to keep them separated. Let's look at our, let's go around our unit circle. So as we go around, at pi over 4, we have the same value for x and y. So tangent of pi over 4 is going to be the square root of 2 over 2 divided by the square root of 2 over 2, which is just going to be 1. That tells us that at pi over 4, our tangent value will be 1. And that goes for every multiple of 2 pi above and below. But it's also the case over here at 5 pi over 4, because tangent of 5 pi over 4 is negative square root of 2 over 2 divided by negative square root of 2 over 2. So at 5 pi over 4, we're also going to have a 1. And similarly for negative 3 pi over 4, because those are coterminal. And at negative 7 pi over 4, because that's the same as it's coterminal with pi over 4. If we keep going around and look at pi over 2, at this point we have 1 for our x, 0 for our y. So tangent of pi over 2 would be 1 over 0, which is undefined. And you may recall from algebra days, if you have an undefined output on a function, that means we have a vertical asymptote there. That's a place where the function is undefined. So at pi over 2, we're going to have a vertical asymptote that is the same for negative 3 pi over 2 because they're coterminal. And if we look down here at 3 pi over 2, the only difference is that's negative 1 divided by 0. Well, that's still undefined. So at 3 pi over 2 or negative pi over 2, these are places where tangent is undefined, and that also means there is going to be a vertical asymptote in our graph of the tangent function. Continuing around, over here at 3 pi over 4, as well as down here at 7 pi over 4. In these cases, our x and y values are opposites of each other. So whether it's negative square root of 2 over 2 divided by square root of 2 over 2, or whether it's square root of 2 over 2 divided by negative square root of 2, either way it's going to end up being negative 1. So in these points, at negative pi over 4, which is co-terminal with 7 pi over 4, and at negative 5 pi over 4, and at 3 pi over 4, and at 7 pi over 4, at all of these points our tangent is going to be negative 1. Now we can use a graphing utility to fill in the blanks, but as we get closer and closer, as we're getting closer to this asymptote, as our y values get larger and our x values get smaller, that's going to make the tangent get infinitely large, and so it's going to approach this asymptote. Similarly, if we approach from the other direction, we're going to get infinitely large in the negative direction. And that gives us our tangent graph. In this case, we're going to look at cotangent of theta. Cotangent, we recall, is either defined as x over y on the unit circle, or it's also the reciprocal of tangent. It should make sense then that everywhere that tangent was 0, such as at 0 and at pi, those are the places where cotangent is going to be undefined. We can also use the other definition. Cotangent of 0 would be 1 over 0, which is undefined. In this case, everywhere where tangent was 0, cotangent is undefined, and that's where we're going to have our vertical asymptotes. And those are going to be at the multiples of pi. Now, looking at going on around the circle, cotangent is x over y, so if x and y are the same value, again, cotangent would be 1. So cotangent of pi over 4 is going to be 1. Same for cotangent of 5 pi over 4. And that goes for any multiples pi greater than these values. So looking at pi over 4, value is going to be 1. 5 pi over 4, value is going to be 1. Negative 3 pi over 4, value is going to be 1. Negative 7 pi over 4, value is going to be 1. Continuing around, at the point where tangent was undefined, in other words, meaning the x was 0, at these points, cotangent is going to be 0. So at pi over 2 and 3 pi over 2, our value is going to be 0. So at these points, cotangent will cross the x-axis. And finally, at the points where tangent was negative 1, and that was at 3 pi over 4 and 7 pi over 4, at those points, cotangent is also negative 1, because the reciprocal of negative 1 is negative 1. This gives us a graph that looks a lot like the tangent graph. It's a bit of a reflection and shifted, and that's because the asymptotes are in a different place. But this is the graph of our cotangent function.